going to work on lesson 7.3, multiplying mixed numbers to find the area of rectangles. So we found the area of rectangles before. Usually we are multiplying a whole number by a fraction or a whole number by a mixed number. Today we're going to multiply by two mixed numbers. But first let's start with our mental math here. 3 feet are how many inches? Well, I know that 12 inches are in 3 feet, or sorry, 12 inches are in a foot, so I could say 3 feet. Multiply by the 12 inches, and I know I have 36 inches and 3 feet. So 6 feet are how many yards? Well, I know a yard is 3 feet, and so I actually want to divide that one there, right? Because I'm going from a smaller to larger unit. So 6 feet divided by the 3 feet per yard, and I get 2 yards. 4.5 feet are how many inches? Well, I know that 12 inches equals 1 foot, and I have 4.5 feet. So I could say 4.5 multiplied by 12. And I could do that a couple different ways. I could say 4 times 12 is 48. And then I know that 1/2 times 12 is 6. So when I add them together, I get 54. I could also convert the mixed number to an improper fraction and multiply that way as well. 2 feet are how many yards? Well, I know that 2 feet, 3 feet is a yard. So it'd be 2/3 of a yard, because it wouldn't be a whole yard because 2 feet is less than 1 whole yard. And our last one's here. Garrett has a game board with an area of 1 square foot. How many square inches is that? So you can solve that one. And then a room has an area of 45 square feet. How many square yards is that? So you can do both of those calculations there. Now, go ahead and turn in your math journal to page 240. It says, find the area of the rectangle, report your answer in square feet. So I want you to take a moment, pause the video, think about how you could do this. You could draw or do some calculations. But I want you to take a few minutes, pause the video now, go ahead and solve, and then come back. Okay, hopefully you've had a chance to do some calculations here. I'm going to show you how I would attack this problem. Instead of drawing it out, you could do that. But I'm going to show you how I would think about it. I would convert both of these to an improper fraction to start with. So I would multiply my denominator by the whole number plus the numerator. So I get 17/2. And then here I would do the same thing, multiply, add my numerator, and I get 2 times 5 is 10, 11/2. And I know 2 times 2 is 4. And then I would do 17 times 11. I should get 187. So I get 187/4 feet. Now we don't want to leave it as 187/4 feet. We want to divide it. So now I would go ahead and divide that out. So 187/4 divided by 4. So I would do, let's see, I see 18 here, so I know I could do 4 times 4 to get 16. I have to put a 0 here, so I add that to make it 40. And then I subtract, and I get 27. Let's see, I know 7 times 4 is 28, so that won't work. I could do 6 times 4, though. So I know 6 times 4 is 24. And I know that 4 can't go into 3, so I have a remainder of 3. So I get 46 and 3/4 feet. So erase this. We get 46 and 3/4 feet. And remember, it's squared because it's area. If it was volume, it'd be cubed. So to show that it's squared, you could write square feet or just simply put the exponent 2. Now, if I was to do an estimate on this, I can see 8 times 5 is 40, which gets me close, and then I have the halves. Don't make the mistake that a lot of people do and say 8 times 5 is 40, and then 1/2 times 1/2 is 1/4, and add that. That would be incorrect. Okay, so the proper way is to convert them to mixed numbers, or sorry, mixed numbers and proper fractions. Again, you could draw lines on the image and do all that, but I think that makes it a little bit difficult when you get into larger numbers. So let's look at the steps here that they tell us to do for number 2. Or they give us some notes up here. It says rename both factors as fractions. So they took 2, the whole number 2 here, and made it 2/1, and then took 1 2/3 and converted it to an improper fraction, just as we did. Then we rewrite the problem using the fractions as factors, and then you just multiply, and you take your improper fraction and divide it back out to get a whole number or mixed number. So let's look at this number 2 here. A typical sheet of printer paper in the United States measures 8.5 inches by 11 inches. What is the area of a typical sheet of paper? So if it helps you, you could draw a picture, but I'm going to go ahead and do the strategy they said, and I'm going to convert them both to regular fractions. So 8.5 by 11. In order to make this a fraction, I have to multiply my denominator by my whole number, plus 1. So I know 2 times 16, or 2 times 8 is 16, plus 1 is 17 over half. And to make my 11 a whole number, I just put it over 1. And I get 17 times 11. And so we just multiply out 17 times 11, and I get 17 there. Put my placeholder, 7. And I get 187 halves. Now, I don't want to say the typical area of a piece of paper is 187 halves. That's a lot of halves, right? So we actually want to divide that out. So then, what we want to do is just say 187 divided by 2. And what I like to do is I look at the first 2 here. I see 2 can go into 18. I know that can go in 9. So I get 18. And I have to put a 0, so I'm going to make it 90. Subtract. I get 7. And I know that 2 times 3 is 6. 2 times 4 is 8. So it has to be 3. Because I can't go over the 7. I get 1. So I add them together. I get 93 and a half inches. Okay, so just to recap, you're rewriting the mixed number and the whole number as improper fractions, and then you're multiplying across. If you end up with an improper fraction as your product, then you want to go ahead and divide and write your remainder as a fraction. Which we did all those steps and we came up with 93 and a half inches. So to go back to this, my number model here would be 8.5 multiplied by 11 because it's area. And we could say it equals 93 and a half square inches. Remember, it's area, so you have to square it. Okay, you see there, you get 93 and a half inches squared. So let's look at B. B says, Kim is making a design that covers 1/4 the square inch. How many times would she need to repeat her design to cover an entire sheet of paper? Okay, so now what we have to figure out is how many times she would need to repeat her design to cover an entire sheet of paper if it's all 1/4 square inch. So take a moment, think about that. So pause the video. I want you to go ahead and try that. See if you can figure that out on your own there. Okay, let's go ahead and look. Hopefully you had a chance to try to figure that out. And let's see if your answer matches up. It'd be 374 times. So you would have to divide 93 and a half by 1/4 because it repeats over and over there. So you would do 93 and a half divided by 1/4 because you're splitting those up into fourths. And so let's look at that and see what that would look like. So 93 and a half. Let's get some new workspace here. converted those back, I would get 186, 187 halves, and I would multiply it by the reciprocal, and then you would work that out there and multiply across, and you would see that you would get 374 times. So we do 93.5 divided by the 1/4, because each inch is split into 4. So we just say 93.5 divided by 1/4. Okay, so look at 3 here. We'll read this, and I want you to try on your own. Emerson is helping his parents order tiles for their bathroom floor. Their bathroom is 20 square feet. They're using tiles that are 1/3 foot by 1/3 foot. How many tiles are needed to cover 1 square foot? So go ahead and pause the video. I want you to take a few minutes and think about that. Okay, hopefully you've had a chance to look at that. And if you look at the very first part, we need to know how many tiles are needed to cover 1 square foot. So we know 1/3 by 1/3 would be 9 tiles, because you're going to need 3. If I draw a picture here for the visual to show you, if I split it into thirds this way and then this way, you're going to need 9 total to make 1 square inch, because it takes 3/3 to make 1 hole and 3/3 on the other side. So it's a 3 by 3, essentially. So a fraction of a square foot is 1 tile. So what fraction of a square foot is 1 tile? So if we have 1 tile out of 9, it would be worth 1/9 of a square foot, because we have 9 tiles, but they're asking us how much 1 tile would be. So 1 would be 1/9, because 9/9 would be the whole number there, or 1 hole. So how many tiles are needed to cover the entire floor? Well, we know we need 9 tiles for 1 square foot, and we have 20 square feet, so 9 times 20 would give me 180 tiles. So total, you need 180 tiles, because we know that 1 square foot is equal to 9 tiles. So I have to do 20 multiplied by 9 to get 180 tiles to cover the entire floor. So go 4 here. Francisco and his aunt are making a quilt. The finished quilt will be 6 feet by 7.5 feet. They're using 1/4 by 1/4 fabric squares. How many fabric squares will fit along the 6-foot side? Okay, so you see 6 feet by 7.5, and then you can see here. So let's think about that. How many fabric squares will fit along the 6-foot side? Well, I know that 1/4 a foot on this 6-foot side, I'm going to need 4 tiles to complete 1 foot. So I want to take the 6 feet and multiply that by the 4 squares I need for each foot, and I get 24. So they'll need 24 fabric squares for that side, because if it's 1/4 for each square, 1/4 by 1/4, it's going to take 4 of them to make 1 foot, and you need 6 feet total. So then the same thing for B. You want to think about it. 7.5 foot side, and I know I'm multiplying that by 4, because 1/4 means I have to have 4 squares to make 1 foot. So then you would just multiply by 4. So I'd want to convert this to an improper fraction. I get 15 halves, multiply by 4 over 1, and I get 60 halves. And if I divide that out, I'll get 30. So here I would need 30 fabric squares, because it takes 4 pieces to make 1 foot, and I need 7.5 of those. So how many fabric squares will Francisco and his aunt need to make the whole quilt? So I want you to pause the video and work that out. And then I also want you to, when you come back, I want you to do D and pause the video. Okay, after looking at this, hopefully you figured out the number model here for how many fabric squares. We know for one side they need 24, and for the other side they need 30. So would I add those together or would I multiply? That's something to think about. So I need 24 going up one side and 30 going the other. So I would actually have to multiply 24 by 30. So and then you can work that out. And what is the area of the quilt to be? Well, I know to find area, I do length times width. And again, you can work both of those out and see what you get there. But I know to find the area, or the whole number of squares I need is the same thing as area. So this is my length times my width. So I would do the 24 multiplied by 30. And then again, I want you to calculate those and figure those out. Okay, so then if you look at number 5, it says Margaret had a piece of checkered cloth like the one shown below. She measured one checker square and found that it is 1/2 inch by 1/2 inch. The piece of cloth has 15 rows of 20 squares. How many checkers covers the whole piece of cloth? Okay, so there it tells you the piece of cloth has 15 rows of 20 squares. So how many checker squares? So we know the area is simply length times width. And they told you that it's 1.5 by 1.5, but right now they're only asking how many squares. So they're telling you 15 rows of 20 squares. So I know my number model would be 15 multiplied by 20. And then on B, what are the dimensions of the piece of cloth? What is the area? Okay, so there's a little bit different because you have to look at this, and each square they're telling you is 1/2. So every 2 would make one whole square foot. So 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, 6 foot, 8 foot. So it'd be 8.5 on this side, 8.5 feet when you count by 2s, because every 2 makes a whole. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be an 8.5 by 10 foot, and that's how you would find the area, or sorry, by inches. And so you count every 2. Those 2.5 inches together makes a foot. So it'd be an 8.5 foot by 10 foot, and that can help you find the area. And you would want to report that in square feet. And then a little more practice here for you. The cover Martinez book measures 7.5 inches by 9 inches. What is the area? So remember to find area, you do length times width. Again, same thing. I could convert these to improper fractions. So I would do 7 times 4 is 28, plus 1 is 29/4. And I would just make 9 a whole number over 1. And then you can multiply and find the area. So remember, area is length times width, unless they give you the base. Area of the base, and that's actually volume. So, all right, so that's the end of the lesson.